We're going to continue with Chapter 2 and Section 2.5, which deals with solving compound inequalities. So we're still in the realm of inequalities, just a different type of inequality that we're going to deal with today. So 2.5, solving compound inequalities. So let's take a look at our first example here. So in this first example, we want to write each sentence as an inequality and then graph the inequalities after that. When we're talking about compound inequalities, there are two types of compound inequalities that we care about. There's the and compound inequalities and the or compound inequalities. And you'll see that there's some important differences when we're talking about both of those. So the and compound inequality, which we're going to look at first, you're going to be ending up shading in the middle region. And you'll understand what I'm talking about when we look at this example. So let's write this. It says a number x is greater than -8 and less than or equal to 4. So we're going to write it at the word and in there first. So x is greater than -8 and x is less than or equal to 4. So and x is less than or equal to 4. So we can write it like that, and let's take a look and graph that and see what it's going to look like. So I know -8 is over here. I know that 4 is over here. So we're saying x is greater than -8. So I have an open circle at -8, and I'd shade to my right. But I'm not going to shade all the way because I know that there's a restriction that occurs at some point as well. It's telling me that x is less than or equal to 4. So I know at 4 I have a closed circle, and I'm going to shade to my left. So there's that overlap here, and the only thing that is a solution, because it has the word and, is anything that is greater than -8 and, so it has to meet that second requirement, less than 4. So anything in between these two numbers would be a solution. -8 would not be a solution because there's an open circle there. 4 would be a solution because there's a closed circle at 4. And any number in between, 0, 1, -1.34576, those are all solutions to the inequality. When you have a and inequality, you can actually smush it together in one form without the word and. So what I mean by that is we'd have our smaller number on the left-hand side, which in this case is -8, and our larger number over here, 4, and x in the middle. And I know x is less than or equal to 4. But if I look, I know x is also greater than or equal to -8, so I can use that same symbol. Notice that the opening is here and here, so I haven't changed anything there. And I end up getting -8 is less than x, which is less than or equal to 4. Most of the times, you'll see your and compound inequalities written in this form here with everything together. When you see that, you know that you're shading in that middle region, and that only the values that are in between those numbers, sometimes including your boundary points, are solutions to your inequality. The other type of compound inequality that we can deal with is an or compound inequality, in which case it only has to meet one of the two things that we're saying. So y is at most 0. At most means that's the highest number that it could be. So I know that y is less than or equal to 0. Or at least 2. So at least 2 means that it's greater than or equal to 2. When we have an or compound inequality, we shade the outsides, because it's only one of those two things there. So we know that 0 is here, and we know that 2 is over here. So y is less than or equal to 0. Closed circle at 0, shade right. Y is, or left rather. Y is greater than or equal to 2, closed circle at 2, shade right. So in this case here, we're shading on the outsides, okay, and we end up getting an answer that looks like that. The ors, there's no way to smash them together, okay? We leave them separate with the word or in between. So those are the two types of compound inequalities that you can see. We'll do the try these in class. Let's look at some more examples here. Now we're actually asked to solve these. I know it's going to be a compound inequality that's and, because I have everything together. There's two techniques that you can use to solve them. show you the first technique, in which case we want to isolate our variable in the middle. In that particular technique, what you're going to do is you're going to get rid of whatever's inside that middle area, similar to like you would solve any equation or inequality. So if I have a minus 2 here, I know that I have to add 2. Now normally we'd say you add 2 to both sides, but you have to add 2 to all sides. Most people forget to add it to the left-hand side there. So make sure if you're going to use this technique that you are doing everything to all sides. So all sides have to receive whatever you're doing. So negative 4 plus 2 is going to be negative 2. This cancels in the middle, which is my goal because I want to get x by itself. And then on my right-hand side, 3 plus 2 is 5. Here's my solution. Is x by itself in the middle? Yes, it is, which is my goal here. And now I can go ahead and I can graph this. Draw on my number line, negative 2, positive 5, open circle at both of them, shade in the middle region there because it's an and, x is less than 5, x is greater than negative 2, and there's my solution. Second way that some people prefer to use is to split up that middle term and create two equations, or two inequalities rather. So in that technique, you'd have negative 3 is less than negative 2x plus 1. And, so now I'm using the word and, negative 2x plus 1 is less than or equal to 9. And then we would go ahead and we would solve both of these inequalities. So subtract 1, negative 4 is less than negative 2x. Divide by negative 2. Your inequality rules still hold here. You're dividing by a negative. So you're going to get 2, positive 2, is greater than x. Solve my second side. Subtract 1. Negative 2x is, again, less than or equal to 8. Divide by negative 2. Divide by negative 2. Again, I have a sign flip. X is greater than or equal to negative 4. I've got the word and in here, but I want to smash this all together and write it as a single inequality. If I'm writing it as a single inequality, we read from left to right, so I want to make sure that I have my smaller number on the left-hand side, which is my negative 4. So I'm going to end up with negative 4 is less than or equal to x, which is less than 2 as my answer. Could I keep it the other way? I could, but I prefer to do it that way. So you can see this is another technique that you can use to solve a compound inequality. Could I have done it my other way? I sure could have, okay? I could have left this as negative 3x, or negative 3 rather, is less than negative 2x plus 1, which is less than or equal to 9. And I could solve it by isolating in the middle. Subtract 1. Negative 4 is less than negative 2x, which is less than or equal to 8. And then divide negative 2 on everything. Notice I'd have a sign flip here because I'm dividing by negative 2. So I end up with 2 is greater than x, which is greater than or equal to negative 4, which is acceptable, but that's a little bit weird because my negative 4 is on my right, and that's really the smaller number. So I can rewrite that in a better way as negative 4 is less than or equal to x, which is less than 2. Notice that's the same answer I got using my other technique there. So it doesn't matter. You can do, you get the same solution. Okay, if you want to break it up with the word and in between, go for it. Let's graph it. It's an and compound inequality. It's going from negative 4 to positive 2. I'm going to have a closed circle at negative 4 because what's the sign that goes with negative 4? It's got a line underneath that equal to. So it's a closed circle at negative 4, but the open circle at 2, because there's no equal sign there, and I'm shading in my middle region there. So negative 4 would be a solution, positive 2 would not be a solution, and anything in between those numbers would be a solution as well. So those are your and compound inequalities, two ways to solve those. And then we have our ors. Our ors are a little bit easier because they're going to be written as two separate inequalities with the word or in between. So we just solve them as two separate inequalities here. So we're going to have 3y minus 5 is less than negative 8, or 2y minus 1 is greater than 5. And just solve these out as two separate inequalities like we were doing. So add 5, 3y is less than negative 3, divide by 3, and you get y is less than negative 1. No sign flip here. I didn't divide by a negative. I divided by a positive. Or let's solve our second inequality. Plus 1, 2y is greater than 6. Divide by 2, and you're going to get y is greater than 3. So this is my algebraic solution, which we want to see. And then we want to go ahead and we want to graph this. So I'm going to have negative 1 over here, positive 3 over here. If I'm graphing this section, y is less than negative 1, I'll have an open circle at negative 1, and I'll shade to my left. And when I graph my second part, y is greater than 3, open circle at 3, and I'm going to shade to my right. Notice the or inequality, we're shading on the outsides of our regions. And they're a little bit simpler, I think, to work through than the and inequalities there. Okay, so we've got our two types of inequalities. We'll go through some try these practice and a word problem in class. But the key thing for you to take away from this lesson here, make sure you know the two different types of compound inequalities, the ands and the ors. The ands, we're shading the middle region, and we can combine them all together like this, or we can write it with the word and. The ors will always remain separate. Those and inequalities, if we're going to solve it using our first technique, make sure that we're adding or subtracting or performing whatever operation to all sides, the left and the right, or we can split it up and create our two inequalities, and make sure that we're shading the middle region. On the ors, we're shading on the outsides. We just treat them as two separate inequalities, and we solve them that way. Don't forget your inequality rules. When you multiply or divide by a negative only, you're flipping the inequality sign. Good luck, guys. I will see you in class.